welcome to the how-to for atoms, mass number, and atomic number. If we first start by thinking about atoms, we know that atoms are the smallest particle of an element. And so what we could have is multiple copies of an element. Okay? And so here we have multiple atoms of an element. If we understand an atom, and we apply John Dalton's atomic theory of matter, which was based on 4 postulates, first being each element is composed of extremely small particles called atoms. So we could kind of show each atom as a different color, where an atom of the element nitrogen has its properties and shows up blue, where an element of oxygen we could think of as being a red sphere. Also, all atoms of a given element are identical, meaning that one atom of oxygen is just like all the other atoms of oxygen, and one atom of nitrogen would be just like all the other atoms of nitrogen. The third postulate was atoms of one element cannot be changed into atoms of a different element, right? We can't just take one oxygen atom and convert it to nitrogen. Otherwise, we would probably take oxygen atoms and create gold, but we know that's not possible. The fourth is that compounds are formed when atoms of more than one element combine. So if we take one nitrogen atom and one oxygen atom, that could form nitrogen monoxide, where we have one nitrogen atom and one oxygen atom that combine together. So we can go from individual elements to a compound. Well, John Dalton's 4 postulates of atoms really helped shape the idea for 3 different laws. The law of constant composition, the law of conservation of mass, or law of conservation of matter, and the law of multiple proportions. So if we turn and think about the size and the mass of atoms, what we know about atoms is they have extremely small masses and extremely small diameters. They are, again, the smallest particle of an element. And so I always like to say chemists came up with a better way to calculate these numbers. And so we came up with conversion factors that got rid of these really, really small masses. So normally we would say that the heaviest atom is about 4 times 10 to the minus 24th grams. But instead of trying to use 10 to the minus 24th grams to always talk about the size of an atom, chemists came up with the atomic mass units, or AMUs. 1 AMU is equal to 1.66 times 10 to the minus 24th grams. This allows us to have much more easier numbers to work with. Same thing when we talk about the size, the overall size of the atom. Most atoms range from about 0.5 times 10 to the minus 10th to 5 times 10 to the minus 10th meters. So again, very small sizes. And instead of having to work with 10 to the minus 10th in all these values, we can turn and use a conversion factor called the angstrom, where 1 angstrom is equal to 1 times 10 to the minus 10th meters. Makes it a lot easier to work with. So now we can say the overall diameter of the atom is about 1 to 5 angstroms. So we really have 2 parts of the atom. We have this central part called the nucleus, and then we have this outside area called the electron cloud. What we're going to find out is that all of the mass in this atom, okay, all of this mass up here, where we said 4 times 10 to the minus 24th grams, the majority of it is really in the nucleus. Okay? And then the outside, this electron cloud, has very little mass. You could also think about it as a football stadium. And in a football stadium, if you took a marble and set it right inside at the 50-yard line, that would be kind of equivalent to the size and the mass of that nucleus compared to the overall electron structure. So when we look at what is inside the nucleus versus the electron cloud, okay, in the nucleus we contain both protons and neutrons. And then the electron cloud is where we keep these other subatomic particles called electrons. So a proton, as stated, has a positive charge. So every proton has a +1 charge. Every neutron has no charge. It's neutral. Therefore, it's called a neutron. And so the protons and the neutrons are really what make up this overall nucleus. But we also have electrons, and these electrons are found in this electron cloud, kind of around the nucleus. Each electron has a -1 charge. You'll also notice that then we can talk about the mass of each individual subatomic particle, the proton, the neutron, or the electron. The proton and the electron both have a mass of about 1 atomic mass unit, whereas the electron makes up about 5.5 times 10 to the minus 4th atomic mass units. Thus, it would take about 1,800 electrons to equal the mass of just 1 proton. And we got these AMU values for the proton, the neutron, and electron by taking the mass in grams and converting it using this conversion factor.